In this video, I will talk about how to apply this method to find the volume of the solid generated by rotating the graph around the x-axis. Okay, so for example, you have the function y. Okay, the function f of x look like this. Okay, this is y-axis and this is x-axis from A to B. Okay, this go from A to B. For example, from A to B. Okay, so the question is, you have to find the volume of the object when the graph of the function f of x resolving, like rotating around the x-axis. So if the graph rotate around the x-axis, it automatically generate an object look like this. Okay, so it will automatically generate the object like this and this one. Right, so you have to calculate the volume of this solid. Right, so the volume of it is provided by this formula. So for the volume equal to pi the integral from A to B, okay, of f of x square, okay, dx. So this is the formula we're gonna use. Okay, so let's do some math together. Okay, so find the volume of the solid generated by revolving the region bound by y equal 3x plus 1. Okay, so I will graph the function. Okay, this is x, this is y. Okay, so the function is y equal 3x. So if you want to graph this function, you have to find 2 points. Okay, find 2 points on the function. Okay, so for example, I will let x equal 0. X equals 0. Y gonna be 1, right? And when x equal 1, y gonna be 4. Okay, so 2 point is 0, 1, and 1, 4. So when x equals 0, y is 1. So this is the point, the first point, this one. When x equal 1, right, 1 here, y equal 4. So 1, 2, 3, 4. So this is 1, 4. This is a point 1, 4. So I will connect these 2 points together, and we're gonna have y equal 3x plus 1 is this line. Okay, so we have to find the volume between this function and y equals 0. Y equals 0 is the x-axis. Okay, x equal 2. So when x equal 2, y equal 7, right? So 5, 6, 7, this one. Right? So when x equal 2 and x equal 0, x equal 0 is y-axis, okay? And y equal 0 is x-axis. Okay? So it's gonna be this area. We have to find the volume of the solid things generated by this region. Okay, so we're going to apply the formula to this question. So the volume is equal to pi the integral from A to B. So you see that this region, right, is go from 0 to 2, right? So the L pound will be 0 to 2, right? And the f of x squared, right? F of x is 3x plus 1, right? So this is 3x plus 1 square dx. Okay, so this is the volume, right? Okay, then pi from 0 to 2, I'm gonna break it down, right? So it's equal to 9x squared plus 6x plus 1 d of x, right? So next one, if you want to calculate this integral, you just find the antiderivative of it. Find the antiderivative of 9x squared. This is going to be 9x cubed over 3 plus 6x squared over 2 plus x from 0 to 2, right? So this one equal to 9. So you plug in 2 to this one function. So it's going to be 9 multiplied 2 cubed over 3 plus 6 multiply 2 square over 2 plus 2 and minus. You plug in 0 to this one, right? So it's going to be 0 minus 0 minus 0. Right? And this one equal to 38 pi, right? And we talk about the shell method in calculus, how to calculate the volume of the solid generated by the region around the y-axis. Okay, so for example, we have a function look like this. Okay, this is the y-axis and this is the x-axis. Okay, from A to B. Okay, so this is the region, right? The question is, when this region rotating around the y-axis, it rotates around the y-axis, right? It's gonna automatically generate a solid, right? And we have to calculate the volume of that solid. Okay, so the first thing I'm gonna do is that I'm gonna cut this region into multiple rectangle. Okay, when I have multiple rectangle, I'm gonna let the rectangle rotating around the y-axis, and it will automatically generate a cylinder look like this. It's a cylinder. Right? Okay. So for example, this is the rectangle. The height of the rectangle is h of x. Okay, and the radius is this one from the starting point to this rectangle. So this one. Okay. So this is gonna be r of x, the radius of the cylinder. Okay, of the cylinder. Okay. So the formula is the volume equal to 2 pi x from A to B. Okay, so h of x multiply r of x dx. Okay, so this is the formula how to calculate the volume when the region rotating around the y-axis using the shell method. Okay, so if it's rotating around the y-axis, the formula gonna be in terms of x. Okay, this is along the y-axis. If the region rotating around the x-axis is rotating around the x-axis, the formula gonna be v equal 2 pi, okay, y equal a, 2y equal b. Okay, h of y, r of y, dy. Okay, so this is the formula when it's rotating around the x-axis. Okay, so let's go to the first example. This is the region bounded by the curve y equals to 6x, y equals 6, and x equals 0. Okay, use the shell method to find the volume of the solid generated when the region revolves about the y-axis. Okay, so first of all, I'm gonna graph the function y equals 6x. Okay, so this is x, this is y. Okay, so when x equals 0, y equals 0, so this point, this is 0, this is 1, 1, 2, 3, 4, 5, 6. This is 6. So when x equals 1, y equals 6. So this point, right? So I will connect these 2 points. So the function, this is the function y equals 6x. Okay. And y equals 6. So y equals 6. So this is this one, this line. And x equals 0. X equals 0. So x equals 0, which means this are the vertical axis, so y-axis. So this is the region, the R. Okay, this is the region, and we have to rotate it around the y-axis. Okay, so first I'm gonna cut this into a rectangle. This is the rectangle. So okay, so this is the R. This is the h of x, right? The height of the rectangle, and this is the R of x. This is R of x. Okay, so we have to identify h of x. What is h of x equal to? Okay, so h of x equal to this line, right? So this line equal to 6 minus the function y equals 6x, okay? So 6 minus 6x, okay? And r of x equal to r of x is x, okay? Is x. So the volume is 2 pi, the interval from x equal to 0 and x equal to 1. H of x multiply r of x, so it's going to be 6 minus 6x, right? Multiply x dx, okay? So it's equal to 2 pi, this is 6x minus 6x squared dx. And x equals 0, x equal 1, right? So this is equal to 2 pi, the antiderivative of 6x is 6x squared over 2 minus 6x cubed, the parentheses, okay, over 3, from 1 to 0, right? So it's equal to 2 pi, substitute 1, 2, so it's going to be 3, minus substitute 1, so it's going to be 2, right? When you substitute 0 to the whole term going to be 0 because it's 2 pi 0 minus 0, so see this is 0, okay? So it's equal to 2 pi, okay? So the volume of it is 2 pi. Okay, so let's go to the second example. This example look exactly the same as the reverse example, but the difference is that the region rotating about the x-axis instead of the y-axis, like the reverse example. Okay, so this is the function we have. This is y equals 6x, right? This is y equals 6. This line is y equals 6. Okay, so this is the region, right? Okay, because it's rotating around the x-axis, right? So we have to identify r of y, right? Okay, and h of y, right? So what is r of y? R of y is the radius. So this is the region, right? So first I gonna cut this region into multiple rectangle. This is one of that multiple rectangle, okay? So when this rectangle rotating around the x-axis, this one is the height of the rectangle, right? This is the height, and this is the radius of the rectangle, right? So what is the height of the rectangle? The height of the rectangle is x, right? Is x, okay? But what is x equal to? X equal to y over 6, right? Okay, so and about the radius is y, right? So the purpose is h equal y, h of y equal x. I transfer x to y over 6 because the interval have to be in terms of y instead of x, okay? So the volume is 2 pi, the interval from y equals something and y equals something, okay? So because the region go from y equals 0 to y equals 6, so y is going to be 0 and 6, right? And radius is y. Multiply the height is y over 6, right? dy, right? So this equal to 2 pi y equals 0, y equals 6, y squared over 6 dy, right? So it's equal to 2 pi y cubed. 3 multiplied 6 gonna be 18 from 0 to 6, right? So it's gonna be 2 pi 6 cubed over 18. So it's gonna be 24 pi, right? So the volume is 24 pi, right? So if this video is helpful, don't forget to give me a like, subscribe. Thank you so much.